All right, hello everybody. My name is Aaron Standard, and today we're working on a new video all about OpenTelemetry. Now, we've done a bunch of videos on this channel. We got a playlist all dedicated to OpenTelemetry. One of our most popular videos here is the Intro to OpenTelemetry for .NET. This is a subject we've covered in depth, partly because we have a commercial product, Phobos, that we built around doing OpenTelemetry for Akka.NET. But also because being able to observe system behavior is really essential for being able to troubleshoot and debug it. And since we deal with distributed systems, this is especially important for us because context for everything we work with is spread out across multiple instances of multiple processes, sometimes implemented in completely different programming languages and runtimes. OpenTelemetry helps give us a unified view of all of that. Today, we're going to talk a little bit about a best practice for working with OpenTelemetry, which is using the OpenTelemetry Line Exporter, or otherwise known as the OpenTelemetry Line Protocol, OTLP, and the OpenTelemetry Collector. So these are two different tools that are all made available by the OpenTelemetry project. They're fully open source, and they will make it easier for you to instrument your application, get rich, usable metrics, and will decouple you from any specific OpenTelemetry vendor. So let's dive in. First, what did things look like before the OpenTelemetry Line Protocol was a thing? Well, basically, you needed to introduce vendor-specific metrics, trace, and log exporters. So you needed to configure, for instance, the infamous Prometheus/metrics endpoint on all of your different servers, which was a little bit of a pain to organize and manage. And not to mention, in the .NET space, they kept moving who that plugin belonged to around quite a bit in the early days of OTEL. There weren't always plugins for some specific vendors. So early on, we were trying to help a customer do some work with Dynatrace, and there was just not a lot of tooling for that in the early days of OpenTelemetry and .NET. This is back in 2022, that time frame. OTEL plugins weren't always consistent with how they handled OTEL standards. And then the last bit of it is that OpenTelemetry was still a great leap forward from having to use vendor-specific APM instrumentation tooling. It gave us kind of a common set of grammars and update terms for doing things like metrics, logs, and traces. But having the exporter set up meant you had to deal with all the quirks that were specific to each platform, such as if you're doing metrics exports, some platforms have a different temporality collection standard than others. And this is instrumentation detail garbage that you really shouldn't have to care about as an application developer. This is where the OpenTelemetry Line Protocol steps in to help make our lives easier. Your application exports everything to the OTLP exporter, which we'll show some source code for that in a moment. So logs, traces, metrics all go through this export pipeline. And this gives us a common wire format that most APM vendors can actually receive directly now. So you don't necessarily have to translate OTEL's grammar directly into something that Datadog can understand. Datadog, Jaeger, Prometheus, and a lot of these other big APM vendors, whether they're open source or proprietary, can all natively ingest the OTLP at this point in time here in 2025. So OTLP is basically a vendor-neutral way of describing over the wire logs, metrics, and traces. And it eliminates the need for vendor-specific exporters. So one more piece of friction eliminated from all of our observability instrumentation needs. And that's great. The OpenTelemetry Line Exporter package is a first-party package shipped directly by the OpenTelemetry project. In .NET, it's all basically ships at the same time any of the other OpenTelemetry base packages get updated. So you don't have to worry about being out of sync or whatever with the way the OpenTelemetry spec is implemented in .NET. This will always be current with that. However, there's more. The other big tool that we can leverage, and this is separate from the OpenTelemetry Line Exporter, is a tool called the OpenTelemetry Collector. This is a standalone application, essentially, that runs usually as a Docker sidecar container, or maybe a daemon set in Kubernetes, or maybe you might have one of these running on each one of your virtual machines if you're doing something that's closer to bare metal or just infrastructure as a service. And what the OpenTelemetry Collector does is it's able to pre-aggregate data that you receive. It's able to batch it. It's able to filter it. And optionally, you can also use it to enrich data to include additional attributes. So for instance, in Petabridge's test laboratory, we have two different Kubernetes clusters. We have an x64 cluster and then an ARM64 cluster. We have customized our OpenTelemetry Collector to add an attribute indicating which cluster this piece of data came from. So if we want to very quickly bisect, was this an x64 or an ARM64 data set, we can do that using the attributes that the OpenTelemetry Collector gives us. And then you can configure the collector to basically ship various outputs to various destinations. So you can have metrics go to Prometheus, and traces go to Jaeger, and logs can go to Seek. Wherever you want to stick your data, the OpenTelemetry Collector will allow you to configure it. And this uses the OpenTelemetry Line Protocol under the covers. It's basically using OTLP to communicate with all these endpoints here. And the nice thing about this is we're even further removed now from having to integrate our application directly against any specific APM vendor. That now becomes something you just configure in a YAML file inside the OpenTelemetry Collector deployment itself. And therefore, you don't need to do things like stick your Datadog key into your application. That's something that now can go inside the OpenTelemetry Collector. This is what the OpenTelemetry Collector YAML looks like. Now, this isn't a full YAML file. We'll show a couple of those in a minute. But essentially, you define your processors. This is where your pre-aggregation, your enrichment, and your filtering can come from. The only processor we're running here is batch. So the ability to kind of essentially group metrics, traces, and logs together before they're sent over the wire. So that can kind of help reduce the strain on the network that we're using. And then we define our exporters here. So I can go ahead and use an exporter for Prometheus. I might have one for Seek, which is going to be where we ship our traces and logs. And then I can go ahead and decorate my pipeline down here saying, okay, all traces go to these destinations and they will use this processor which will run before they hit the exporter. And we'll have a processor and an exporter for metrics and a processor and an exporter for logs, all that good stuff. So we've already kind of covered the bullet points on the right already, but the long and the short of it is that the OpenTelemetry Collector allows you to further decouple away from your APM vendors and also allows you to do some things locally like pre-aggregation, batching, and filtering that will make it easier for you to go ahead and transmit all of your metrics and traces and logs to wherever they need to go using less bandwidth typically. If you've batched a bunch of these traces together, you're going to be using fewer network round trips than you would have otherwise. So there's a lot of advantages to doing it, and it's very easy to go and set this up. So we're going to dive into a little code sample that uses Phobos, Akka.NET, ASP.NET Core, etc. And it uses .NET Aspire and the OpenTelemetry Collector at the exact same time, which is something that you can configure pretty easily all on your own. That way you can leverage Aspire to go ahead and view traces and metrics, but you can also use tools like Seek and Prometheus, which we'll see in just a moment. All right, so we're going to take a look at a few different code samples here just so you get a kind of a complete picture. The first one we're going to take a look at is our Memorizer MCP server from one of our previous videos, since it uses the OpenTelemetry exporter pipeline. And you can see here that we have this extension method off the service collection where we do all the normal OpenTelemetry stuff. Then all we do here to enable it is call use OTLP exporter. And you can find this source code here up at this repository. I'll include a link in the description. But the big code sample we want to show off is also open source. This is the petabridge.phobos.web repository. This is the repository that we use for helping customers who are basically trying to learn how to use Phobos, our commercial product for Akka.NET, learn how to use that to basically build dashboards and to understand behavior of their own applications. And we just recently converted all of this to use .NET Aspire. And what I'm going to show you real quickly here is how to launch this and use the OpenTelemetry Collector alongside .NET Aspire. Now, if I go to the actual source code here, the application is running currently, you'll notice we do not have an OTLP exporter built into this at all. That is because when these environment variables are set, we will automatically export data using the OpenTelemetry exporter protocol. And .NET Aspire more or less injects these into the application, since that's normally how Aspire listens for your input, is it does that sort of implicitly. So we have our OpenTelemetry exporter running under the covers. And this little bit of code right here is our OpenTelemetry Collector. Now, I'm not going to explain all of the Aspire specific stuff in here, but long story short, this is designed to go ahead and receive a bunch of environment variables that are injected into it by .NET Aspire when it spins up. That's going to include things like the Aspire endpoint, the API key, the Prometheus endpoint, the Seek endpoint, and so forth. This telemetry stack very closely matches or resembles what we use in production for monitoring SDKbin, our test laboratory, and a lot of other different environments that are important to us here at Petabridge. So we're going to take a look at all of that right now. So if I go to, let me reload this real quick. Okay, so I can see all of our resources here. We have a 3-node Akka.NET cluster. We have Grafana. We have the OpenTelemetry Collector up and running. We have Prometheus. We have Seek. Let's go ahead and generate a little bit of HTTP traffic first. This application is not much to look at. But first place we'll take a look for some of our data and traces is we'll go to Aspire itself, and let's look for the Phobos web application. And you can see here that we had, a failed attempt to communicate to Azure Table Storage. We use that for service discovery, I think. And then largely the rest of the communication here is all internal. So that's one set of resources that we have. And the Metrics Explorer in Aspire is decent as well. You can take a look at things like the number of unprocessed messages sitting in actors' mailboxes, that type of thing. But if you really want to get a good view of your metrics, this is where the OTEL Collector is really useful. You want to transmit it to some tools that are a little bit more specialized and allow you to build richer views of what's happening inside your system. We're going to use Seek for looking at logs and traces, and Prometheus is going to store our time series data for all of our metrics, and Grafana will give us a nice dashboard we can look at to help interpret those. So let's look at Grafana first. We're not going to belabor the point here and spend a huge amount of time looking at it, but this is the Phobos dashboard, and I can see here that I've got these 3 instances. They're all up. They all have 8 actors each. Only one of them has really processed any messages at all recently. And I can go and take a look and see the total number of actors alive on each system and the message throughput and how many messages they processed, etc. That's sort of our standard view of what OpenTelemetry metrics might look like. And then if we take a look at Seek, and bear in mind, Seek's getting the exact same span and trace data that Aspire is as well. So basically information's going from the collector to .NET Aspire. It's also going to Prometheus, and it's also going to Seek. That's the beauty of what the OpenTelemetry Collector will let us do, is kind of transmit this information to multiple destinations. Let's take a look at this HTTP request here and show it. So this is a full end-to-end request from hitting this endpoint right here when we go ahead and load our application. This is going to basically trigger an HTTP request. So if I go ahead and let me do this real quick. Let's do find. So I can see the histogram up here, and then I can also see all of the spans and log messages individually. But the point of this video is really to harp in on the OpenTelemetry Collector and the OpenTelemetry Line Protocol. Both of these tools will give you a much more consistent view of your applications and all the different environments you might want to use for doing analysis. So in our case, we're using 3 different ones: Aspire, Seek, and Grafana. So it makes it really easy to support all 3 of those. It can support pre-aggregation, and it can also support some things like data enrichment. So let me show that real quickly. This down here, let me double check. This is doing here we go, a little bit of data enrichment for Prometheus. This is our production configuration for working with the OpenTelemetry Collector inside the Kubernetes clusters that SDKbin runs. So this is a Pulumi application, and this is going to get deployed as a config map for the OpenTelemetry Collector daemon set. We're using the remote write endpoint for Prometheus because we actually host all of our telemetry systems outside of the Kubernetes cluster. So we're going to push all that data out to a virtual machine that's inside the same network as our Kubernetes cluster is. We use the Prometheus remote write, and one of the things that we specify down here, this is a form of data enrichment specific to Prometheus. We say we want to go ahead and convert all of the resource information. So that's things like the name of this instance, the namespace that it's in, the version of the application. All that stuff will get converted into attributes that I can use on the OpenTelemetry dashboard, which is exactly what, if I go here, this is the actual production version of that Phobos chart. If I pull this up, all this information here, SDKbin production / NuGet service, this all comes from those OpenTelemetry attributes. And so the OpenTelemetry Collector will transform those metadata attributes into tags that I can now query from Grafana on Prometheus. So the OpenTelemetry Collector is really powerful. It's also very efficient, and it's all open source. You should definitely go check it out, start using it inside your applications, and make it kind of a part of your formula for how you deploy applications with observability in .NET. Well, that'll do it for this video. If you found this video useful, please don't forget to check the description to find links to other resources we may have included, so blog posts, GitHub code samples, other videos, so on. And as always, don't forget to like and subscribe and ring the bell for notifications. We'll catch you next time. Thank you very much.